Asteroid 2022 RD2. From mini-moon to potential impact, risk a newly identified asteroid, designated 2022 RD2, presents a rare celestial event. It may briefly become a temporary, mini-moon, orbiting Earth before potentially shifting onto a collision course decades later. This space rock belongs to a class called Arjun's asteroids, with orbits closely aligned with Earth's, making them unusually slow-moving and susceptible to temporary gravitational capture. The dynamics of a temporary moon-Earth's gravity can sometimes trap these slow-moving asteroids, causing them to orbit our planet for a limited time. This phenomenon creates what astronomers call mini-moons. Simulations suggest 2022 RD2 could enter a temporary orbit around Earth between 2043 and 2044, remaining a satellite for several months before drifting away. A shifting trajectory and potential hazard, however, the asteroid's path is unstable. Researchers in Madrid found that 2022 RD2 has an extremely short Lyapunov time, a measure of orbital unpredictability, meaning its trajectory can change dramatically within just a few decades. Some projections indicate a potential collision path beginning around 2080, though NASA estimates the impact probability is less than 0.1%. Why this matters? A rare opportunity and unclear origins, the study of Arjun's is significant for two main reasons. First, these asteroids are relatively accessible for space missions, offering potential targets for testing technology or even resource extraction. Second, some may be fragments of the moon ejected by impacts, providing insights into lunar geology. Despite being close to Earth, these objects are difficult to study due to their short visibility windows and erratic orbits. Conflicting data and long-term prospects, while NASA's models suggest a low impact probability, the asteroid's small size, roughly the size of a three-story building, means even a collision would likely cause limited damage. The research highlights the dynamic nature of near-Earth space and the challenges in predicting long-term asteroid trajectories. The study of this population is just beginning, and while a future collision cannot be ruled out, the insights gained will refine our understanding of the near-Earth environment and the origins of these mysterious space rocks.